Hello and welcome back to my channel. Once again, this is teacher Jesse, and today I will be discussing with you about how to find the area of composite figures. So composite figures are figures like this. It is a combination of two or more geometrical shapes, like for example a square and a rectangle, or a triangle and a circle, or a trapezoid and any of the other polygons. Okay, so this is the Math 6 Quarter 3 Module 5 of Davao City Division modules. But before that, to those who are not yet able to subscribe to my channel, please don't forget to subscribe and click the notification bell so that you will get updates on my Math tutorial videos that I'll be uploading soon. Okay, so this time we are going to start with a drill. What you're going to do is you're going to give the area of each figure. I will give you a few seconds before I'll reveal the answer. Or you can pause the video if you need more time. Let's start with this a square with a side of 10 centimeters. Okay, so the correct answer is 100 square centimeters because it is 10. The area of a square is a side square, or side times side, and it is 10 times 10, which is 100. Let's continue. A rectangle, which is a 20 centimeters by 5 centimeters. Go. Okay, so 20 times 5 is 100. So any parallelogram is having the formula of base times height. So this is 20 times 5, which is 100. Continue. A triangle, which has a height of 8 centimeters and a base of 6 centimeters. Go. Okay, so 8 times 6 is 48, and remember, if it is a triangle, we are going to divide it by 2. 48 divided by 2, or 1/2 of 48, is 24. Okay, next. I guess it's the last one. Okay, this looks like letter L. This is 3 centimeters. This is also 3 centimeters. And so with this, and this is 9. Go. Okay, I hope that you got the correct answer. So this is 36 square centimeters. How? So it is 9 times 3, which is 27. So this portion is 27, and 3 times 3 rather is 9. So 27 plus 9 is equal to 36. Did you get the correct answer? Okay, great job. But anyway, we'll be discussing some an example of this. This is an example of our topic for today. This is an example of a figure which has a composite area because it is combination of two geometrical shapes. We have the square and the rectangle. Okay, so we are going to continue. Did you know how to get the area of an irregular figure? Okay, when you say irregular figure, it looks like this. So if you are going to observe, it is combination of two or more shapes, and given that these sides are just equal, and the dimension of this is 4, so of course if this is 4, this is also 4, and so are this. And this is 12, and then so as you can see, 4 times 3 is equal to 12, and this is 8, so it means this is also 8. Okay, so how are you going to get the area of this? So let's have first a short recap about the concept of the area. Area is the number of square units in a given figure. So number of square units, take note of that, square units. For instance, this is a square, 1 square unit. So we are going to conclude that this is having a square area of 3 square units. Okay, 1, 2, 3, because it consists of 3 squares. This one has 1, 2, 3, 4, 5, 6, 7. So this has 7 square units. That's the area. And from that given concept, we can say that the area of a regular figure such as squares and rectangles can easily be identified by multiplying the sides. For example, this one, this is a 3 by 3 square, so it is 3 units by 3 units, which is 9 units, so that's the area. By counting and by multiplying 3 times 3. This one also is 2 by 4, so 2 times 4, which is equal to 8. And by counting also, we have 2, 4, 6, 8. So we can get easily by just multiplying. So if there is a given unit of measure such as cm or m or feet, the same concepts will do or apply. For example, this one is 3 cm, then it is 3 times 3, which is 9 square centimeters. Take note, there is an exponent, means cm times cm is equal to cm squared or squared centimeters. This one also is 8 squared meters because this is meters and this is also meters. Now let's apply the concepts to the given irregular figure a while ago. This one, so these are the dimensions. So this is 4, this is 4. So what do you think are we going to do so that we can get the area of this irregular figure? Actually, it has composite area because it is a combination of different figures. Like for example, this one is a rectangle, this is a square and a rectangle. Or you are going to look this way. This is a rectangle and there are 2 squares. So solution number 1 is to solve the area of the figure by dividing it into sections. Like for example, this one, we're going to divide it into 3 sections. We have a rectangle, a square, and a rectangle. So for the rectangle, this is 4 centimeters, so this is also 4, and this is 8, therefore this is also 8, and 8 times 4 is equal to 32, right? And this, they have the same area actually with this one, okay, obviously by just looking at it. And by plotting the dimensions, of course, they got the same dimensions. And this one is, since this is 4, and this is also 4 because of the symbol, so it is a 4 by 4 square. So if we're going to get the area, it's 32. 4 times 8 is 32, and 4 times 4 is 16. And then to get the composite area of this irregular figure, then we are going to add the 3 areas. 32 plus 32 plus 6 plus 16 is equal to actually 80 squared centimeters. Therefore, the area of the irregular figure which I shown a while ago is 80 squared centimeters. Okay? So we have also solution number 2. We assume that the area of the area is a regular figure, then we add or subtract the area of the missing or added parts. Like for example, this one, we take this as a rectangle. Okay? So for example, since this is 12 and this is 8, we are going to multiply, or we are going to assume that there is a broken line. So this is a complete regular figure which is a rectangle. So we are going to simply multiply 12 times 8 because the dimensions are 12 centimeters by 8 centimeters, the length and the width. So we have 12 times 8, which is actually 96 square centimeters. Then what we're going to do is we are going to subtract this unshaded part, or this portion, like this. And we know that this is 4, so this is also 4, and it is a square. 4 times 4, which is equal to 16, and we subtract, of course, this one. So 96 minus 16 is actually 80 squared centimeters. And if we are going to compare the two answers, we have 80, and solution number 2, we got the same answer, which is 80 squared centimeters. So this is how, or those are the steps on how to solve for the composite area of an irregular figure. Okay, so this time it's your turn. Can you solve for the area of the given figure? So this is the figure. This looks like capital letter H. This is 10 centimeters, and this are meters rather. And this is 30 meters. Okay, you can pause the video and feel free to answer and compare your answer as when I reveal the answer later. Okay, so I will now reveal the answer. So if you're going to solve for this, I will show to you 2 different ways, just like with our previous discussion. So this is the figure, and it can be divided into 3 different figures. We have the first one, which is a rectangle, the second one is a square, and the other one is a rectangle. So the dimensions for the first one, since this is 30, so this is also 30, and this is 10. This is 10, and this is 10. And this is 10, and this is 30. 30 times 10 is equal to 300. 10 times 10 is 100. And of course, we've got the same area for the two of this, so this is also 300. And then if you are going to add 300 plus 300 plus is 600 plus 100 is 700. Therefore, the area is 700 square meters. Okay, did you get the same answer? Very good. For solution number 2 is, we are going to assume that this is a square. Okay, by completing the figure by drawing a broken line or two broken lines, it looks like this. Since this is 30, this is also 30. Okay, because it is 10 plus 10 plus 10, which is 30. 30 times 30 is 900 square meters. And then we are going to subtract the 2, which is 100, because it is 10 by 10, 100 and 100. 100 plus 100 is 200. 900 minus 200 is equal to 700 square meters. And if we are going to compare the two answers, for the solution number 1, we got 700 square meters, and for solution number 2, the same answer came out. I hope that you got the same answer. Okay, let's continue with an example number 1 given on your module. So this is the figure. It is it shows the shape of the Kenneth's playroom, and what is the area of this. So if you are going to observe, there are two kinds of figures. We have a triangle, and this one looks like a square or a rectangle. So let's take this figure first. We have 5 meters by 4 meters, so the height is 4 meters, and the width, the base is 5 meters. So 5 times 4 is 20, divided by 2 is 10. Always divided by 2 when if it is a triangle. And then the other, of course, we've got the same size, so they are just congruent figures, so it is also 10 square meters. And for this one, this is 5 and this is 5, so it is a square. I'm sorry for this figure, it should be a square. Just follow this illustration. Okay, so perhaps I can stretch it. Okay, so that really looks like a square. Okay, after stretching it, then it is 5 by 5, which is equal to 25. And then we are going to add 10 plus 10 is 20, plus 25 is equal to 45 square meters, and that's the area of Kenneth's playroom. Okay, so this is also an example of a figure which is having a composite area. Next is the composite figure. Looks like this. Looks like a house, the shape of a house, and then this one might be a, I do not know, I'm not sure. Okay, so anyway, I will just divide it into different parts. We have first a triangle with a height of 8 meters, and the width is, or the base is, since it is 30 from here going to here, and from here going to here is 10, and this is also 10, of course this is 10 to get 30. So 8 times 10 is 80, divided by 2 is 40. The second figure is, this is 10 and this is 10, so this is a 10 by 10 square, and 10 times 10 is 100. This one is, this is 30 and this is 4, so it is 30 times 4, which is equal to 120. Okay, so 120 plus 100 plus 40 is equal to 200. 120 plus 100 is 220, plus 40 is 260 square meters. Next, example number 3. This time it consists of a circle. Find the area of the shaded region. So our target is to find only the area of this, so we can apply the technique which I presented a while ago, which is getting the area of this figure, this one, and then we are going to get the area of this enclosed circle, and then we are going to subtract. So first is we are going to get the area of this 14. This is 14 by 14, so 14 times 14 is 196. And the area of the circle, okay, so the radius is 7 because it is 1/2 of 14. So what we're going to do is we are going to apply the formula. Area is equal to pi times r times squared, or pi r squared. 3.14 is the representation or the estimated value of pi. Okay, so 3.14 times 7 squared, or 7 times 7. 7 squared is different is 7 times 7. It is not 7 times 2. That is the common mistake among the learners. So next is 3.14 times 7 times 7 is 49, and 49 times 3.14 is actually 153.86. Then we are going to subtract this from this 196. So the composite area will be 196 minus 153.86 square meters, and the result is 42.14 square meters, and this is our answer, our final answer. Okay, this time we are going to apply what we've learned in the Let Us Practice activity of your module. So the question number 1 is, look at the figure below, then what steps could be used to find the area of the composite figure? So yeah, we are going to identify which is the correct answer. Let's start with letter A. Find the area of the triangle. That's correct. Find the area of the rectangle. Okay, good. And then add the areas. This is exactly what we are looking for. Okay, we are going to get this one, and then we are going to get the area of this, and then we just add. Okay, the rest are incorrect answers. Like for example, letter B. Let's take a look at the different or the other options. Find the area of the triangle. Find the area of the rectangle and then subtract. It doesn't make sense. Why don't you need to subtract? It is not including, or it is not involving shaded parts and unshaded parts. Okay, letter C, find the area of the triangle, find the area of the square. It is not a square, and then add the areas. No. Find the area of the triangle, find the area of the square. It is not a square. Okay, we are going to continue with the next item. What is the area of the composite figure? So this one is since this is 8 and this is 4, this should be 4. It should be a square. Okay, sorry for the illustration. So 4 times 4, which is equal to 16, and this one is 4 times 10 is equal to 40. 40 plus 16 is equal to 56. Okay, so this is 16. I'm sorry, I need to illustrate. This is 16 and this is 40. 10 times 4 is 40. So 40 plus 16 is 56 squared centimeters. This one, 56 cm, is not correct because the correct units of area is in square units. Okay, so this time we are going to continue with item number 3. Find the area of the composite shape shown below. So this is a combination of a rectangle and a semicircle. When I say a semicircle, it is 1/2 of the circle. So first, we are going to separate the two figures. We have a rectangle 24 feet by 15 feet, and 24 times 15 is equal to 360. Okay, you can check using your calculators if it is correct. And then the semicircle, so it looks like this, and the radius is, since 1/2 of 24, the diameter is 24, so 1/2 of 24 is the radius, and we need the radius, and it is 12. So from here going to the midpoint or the center of the circle, that's 12 feet. So we are going to apply the area of a circle. Area is equal to pi r squared. It is 3.14 times 12 times 12, which is equal to 144, and 144 times 3.14 is equal to 452.16. However, we are looking for the semicircle, so we just need 1/2 of this. So we are going to divide it by 2, and the answer is 452.16 divided by 2 is equal to 226.08. You can counter check using our calculators if it is correct. And then 226 plus 360, then we are going to add. The composite area will be like this. 360 plus 226.08 is equal to 586.08 squared foot. And this is the composite area of this composite shape. Okay. So, for your enrichment, what I want you to do is you are going to find the area of the composite shapes given. We have the first one, which looks like capital letter E, and this one looks like stairs or a stage. Okay, platform. So what you are going to do is try to solve for the composite area of these two figures, and then you can write your answers in the comment section below. Okay, so I think that's all for today. I hope that you have learned something, and if you learned something, please like this video and share it with others so that this could be of help to them, especially learning this time of distance learning modality. And even if during the resumption of the face-to-face classes, these videos could help them a lot, especially those learners who are really struggling in learning mathematics. Okay, and again, if you haven't subscribed yet to my channel, please subscribe and click the notification bell so that you will get updates on my upcoming videos. That's all for today. Thank you very much for watching. See you next time.